Okay, for the question, exercise 1 to 3, the chief would like to export his data into another program for analysis, but there must be a field describing which station responded. So the field district has a number that designates the station code, but the chief would like it in the format station 1 instead of the code, and a text field to the table file runs 2010 and name it station, then write a script in the field calculator that will populate the field with the appropriate text. So we have 151 and 551 both equals to Oleander Station 1, 152 and 552 Oleander Station 2, 153, 553 Oleander Station 3. So now we use the if and our if. Alright, so now I forgot return Oleander 3. I had it twice. Okay. Now we define the district number, and if district number equals 1115 or 1551, then we return to Oleander Station 1, and else if this equals this and return this, and else we have this. Let's see. Oh, we failed again. And let's see. Okay. Let's go back to look the exercises real quick. So we have this. We don't have to say anything else. We can just print this, and we don't even need anything. Alright. Return. And let's see the indentation. It's just so difficult to see in here. Okay, we define this. Oh, I do need. Okay, define this, and we will have this number. Okay. Yep, okay, this will be station number. Let's see it better. Okay. Okay, district. Need a T here, district. Okay. If district number district. L if. Define function station number, district number, and semicolon. No, just column. District. Function define function station. Okay. And street number. If a street number is for, or district the number 551, column. We return Oleander Station 1. Our if this. Okay. 552. Return Oleander 3. District. Okay, define station number, district. And inside district number. District number. District number. let's see. 552, 552, 551, 5115. Yeah, we do have 115. We don't need stripped. District. Station. Oh, I have a T here. Sure. This is difficult to look. Oh my god. Alright, we did it. Okay. Now the code. That was this one. Alright. So okay. That worked. Okay. Except here I mistyped a station down below. Alright. So now let's review what we went through. So the field calculator can get complex. It's just difficult to see. And the trick is to maintain the indentation because the code block box does not handle index level automatically. And it's just too tiny for me to see as a good idle would. And it's sometimes good practice to build these statements in the idle using some preset dummy data variables to test the syntax and set the indentation correctly, and then we can copy and paste the code to the field calculator. The same rules that apply to if statements in the label expression dialog box also apply to if statements in the field calculator dialog box. We follow these rules carefully and text any condition statements to make sure that they will not send your code out of control and that they have an instance that equals to true. In both the field calculator and label expression dialog boxes, we are required to manage the indent levels. Because of this, it is good practice to test your code in an idle first for syntax and an indentation before placing it in the field calculator. It is also advisable to calculate values into new empty fields rather than to calculate values over existing values. If something is wrong in your code, it will destroy the original data value. The values would be impossible to recover if you were calculating outside an added session. So this will help the condition statements using string values. So if the fields or values being compared do not match in case uppercase, lowercase, or a combination thereof, the values may not equal to true even when they are the same except for case. So in this instance, we can use one of the strings formatting functions to force the case to match before performing the testing. So now we're going to do some questions. So the first one, I'm going to bring it here, is could the same script, so same script using rather than write code can be done. So it will be the operation. Okay, right here. So the operation is here that we have is could these same scripts be used to display labels on a temporary basis rather than storing it's in my syntax. Let me go back to syntax. I put the question in syntax right here. Okay. Could these same scripts used to display labels on a temporary basis rather than storing the output string in a field? Write a code example to complete the exercise as a label statement. So absolutely, the same formatting and concatenation will work as a label. The function is identical. So, alright. And what other string formatting statements are available for use in field calculator scripts. We write the code to compare name fields from two different tables. If the first is name and store a value in upper and lowercase letters, and the second is empty name and store a value in all cases letters. So the second one should be that if last it will be if last statement name dot lower equals empty last name dot lower, then 1, 2 print. These are the same, and we could try it. So all of them. Okay, and the last one, where did it go? The operation. Let's go back down. Okay, operation, that's syntax, and operation, Python operation comparison. So now for besides using double equal signs, equal sign for is equal to what other equation, what other evaluators that are available in Python. Write the code to find pipe size starting at 8 inches, and that we can do is if pipe size greater or equal to 8 and pipe size is less than 12. Remember the column 1, 2, 3, 4. Print, and you can just say found the correct pipes. Of course, you have to define the pipe size. We will go over and do a lot of exercises to help understand how to put these things and print things, the very basic, together. Okay, but before we do that, I want to finish chapter 1 first, and then I will go over some of the basics about string and how to convert them, and some of the very, very basic part of Python scripting. Okay, now we will do is decision making in the field calculator. Complex operators in the field calculator can include advanced Python math functions and if else logic. We're going to write a Python code block and use if else logic text formatting. And now we're going to do is for tutorial 1 to 3, we'll already learn to perform various text formatting techniques in the field calculator. The field calculator allows you to perform a variety of math functions as well. Python has many math expressions built in, such as adding, subtracting, multiplying, dividing, exponentials, and square roots. So it's all here. And how we do it, so this is for operators, not equal, equal not, and then greater or even. Okay, but Python also has a math module that can be imported and add to higher level math operators. So this scenario uses simple math operators, but we can explore other Python code preferences for more options. Now, the exercise 1.4 we're going to do is the city engineer is preparing to do a flow rate study on the sewer system data. It is a gravity flow system, and the flow rate in gallon per minute (GPM) of wastewater must be calculated for each pipe size. In addition, she wants you to include a jag coefficient for the different pipe materials, because some types of pipes are not flowing at the optimum rate due to friction or buildup in the pipes. Because you don't know the slope of the pipes,